Okay. So in the course spec, Pascal, it's called, like the new abstractions that we have are correct. That's what I mean. Like, so we have wrapping types. That is basically non-null and list. And then these are type definitions. Hi, Martin.
Hello.
Yeah, I probably have to rename this as well.
Course spec.
Especially because I mean reference fields and so I probably rename everything to definition.
Yeah, you can look in the abstractions that we have now.
Yeah.
Okay, so far it's a Chili Cream and Apollo retreat.
Yep.
Go to the Bahamas next time.
Well, actually, we just got back from Arizona. I just got back
nice.
a few hours ago, so I'm still pretty tired and jet lagged.
But I love Arizona. Like I was there last year, and like it has amazing national parks.
Oh yeah, I mean we didn't get to go to the actual national parks, but we had some pretty nice like a nice mountain and some hiking possibilities nearby.
Yeah, also the red rocks that you have there. It looks impressive.
Yeah.
We are complete.
But if I fall asleep halfway through the meeting, you know why
I don't know.
that happens.
Okay, let's start then. So just check. Okay. So let me all remind you that by being here, we all agree to the GraphQL Spec membership agreement and the GraphQL Code of Conduct. Let's do a quick round of introduction in the order of the agenda. I'm Michael, and I'm the host today.
Yeah, I'm Sachin. I'm an engineer from Apollo.
Hi, I'm Pascal.
I'm Martin, also from Apollo.
I'm Derek from Apollo.
Awesome. We have a couple of things on the agenda, actually 3, and I ordered them so that we don't lose ourselves and look up in key discussions. So let's start with a discussion on the union merge. That's what we intend to do there, and what edge cases we see. So maybe Pascal.
Yeah, I need share rights. Otherwise,
Yes.
I cannot share. So I'm working a bit and cleaning up what we have in the spec. Now, one thing that we discovered today is about what we do with unions, because we checked back with what Federation does currently, and you use unions for unions to merge unions. And we just have to discuss this through quickly, because there's a few edge cases where maybe a warning or even a restriction would be interesting. So let's say we have a union. So this is schema A. And we have actually, let's take the federation example. That's what we were.
Yeah, that's a very good example actually to illustrate.
One second.
The
I have it
issue-
in one of my tabs. Sorry, I was prepared and then I probably have closed it. I know it's the it was union
It's
media,
media, no? Yeah.
and there was let's call it the movie and the TV show, and in schema 2. In schema B, we have the union media with the movie and the podcast.
Yeah, it was with book, but
Yeah.
the same thing.
Yeah.
So now what comes out merged is this, right? You have the podcast. There we go. And we have the TV show. So that's the merged output. Now, this works and it makes a lot of sense, but there's one edge case where this becomes a bit interesting. Let's say we have a type object and this has a field media. Everything is fine. We live in a safe space. But what happens if this field is shareable? Because if you think about it, as soon as this has an ID, and we have lookups as well, type query lookup, object by ID. In both of the graphs, we kind of have a problem. Because if this field is shareable, in this specific case, this would mean that it ever can only be movie from a data integrity perspective.
Ah, that's interesting.
Yes, it's like we.
But it's completely fine if it's just a list. Like if there's a list of movies that are returned from, like if you have the query thing, the query, and we have on one graph we have the movies and podcasts, and on the other graph we have the movies and shows, then this is fine. We don't have a problem. We live in a safe space because this goes to schema A and this goes to schema B, or the other way around actually. So it is.
The question is not to necessarily say it should be intersect, but maybe in the case that this is used on as a shareable, and you have this discrepancy between multiple subgraphs, then at least to give a warning, because maybe people don't even realize that they run into this issue. Sashi?
Yeah, so there's some use cases today where I actually do want union behavior in cases like these. Specifically, if the media field might be shareable across subgraphs, but it's possible that the ways you access that media field are on different paths, right? So it could be the case that there is media on one subgraph and media on another subgraph that's shareable, but in that subgraph A, let's say, media is only accessible on certain paths like foo.media, and another the other subgraph could be bar.baz.media. It's possible that those behavior are different and they actually do return different things in those cases.
Yes.
Yeah, but
Yeah, this makes total sense. I mean, the list case is one example where it makes sense, or as you said, when you actually have different sub structures which share the same union name, that's also fine. But it was just a realization that because at the moment, what we did in our implementation, or what we have in the spec discussions in the issues, was actually we switched it to intersect. But that's probably something that we just need to clarify quickly. Do we want to go with union or with intersect? Because that requires a bit of rewrite in the spec.
It's also interesting, like the typing that we're talking about here, and these like, as output types, like from a client perspective, what you're basically what you basically have here is still a valid
Yeah.
a valid type. It's just that certain conditions may or may not occur. But you will never get into a situation where like what you return doesn't satisfy the type condition. However, the semantics of shareable
Exactly, it's about the semantics, right? And the data
yeah.
integrity. If you, depending on your query plan, would get a different result here, then there is kind of an issue.
Yeah, I don't think we ever, but Sachin might have a better understanding of this, but I don't think we ever sort of narrow types based on the path or anything, right?
Right. So in this case, we don't narrow types based on the path, but I guess what I'm saying is it's possible this is still valid according to the definition of shareable because the context in
Yeah.
which media occurs in both subgraphs could just be different. The
Yeah.
way you read media in one could be different from the way you read media in another, and in those cases, you just might get different outcomes from media in that case, and that still could technically be valid according to shareable because they just never intersect. This is the context never intersect, if that makes sense. But yeah, it is a case where at least if you thought about media outside the context of like the path you took to get there, you might think it might be intersect.
But there's never a situation where we break the contract, right? Like the contract that's specified both by the typing and by shareable.
Yeah. I mean, you shouldn't. When you say the contract, you mean the contract of shareable? Sorry.
No,
Yeah. So
contract.
from a schema perspective, there's the typing. So we have the merged union here, and then we have the semantics of shareable, which is that every subgraph should return the same value for that field. And I don't think we ever break that contract.
I mean, kind of.
Yeah, it could even Pascal could model it even worse, right?
Not with union, but with enums. You know, the output only enums, the input only enums. You could argue that this is also path dependent. You know.
Yeah, there's a runtime error actually, but in this case, you could also model it in a way that it always gives you something different, right? If you have the one union has just movie, and the other on the other graph has just podcast, and then you have a lookup on this, and depending on which query plan is more successful or is better, you get a different value, always a different value. Not that this is an edge case, right? It's just should we, because we could detect that, should we at least have a warning for this, or are we okay? Or
when you say we can detect this, do you mean at composition time or at runtime?
Yeah, at composition time.
I don't think we can detect it at composition.
Why not?
You could theoretically figure out whether there's paths that are the same that could be evaluated on both graphs, right? And if that's the case, you should have the same context. In that case, you would expect them to be always returning the same things in that case. It might be a bit trickier too because it's possible that because the fields upstream may also compute things differently, that also changes the context. So maybe it's a little trickier than just that. Like when I say the phrase context in this case, it could be affected by a number of things. So
it's also go ahead. Sorry, I thought you finished.
No, I think that's mainly it's just like what I'm saying is that because the number of things that can affect like what media isn't affected by just the like essentially the object it's on right now. It could be affected by things upstream. I think that's what makes it a bit complicated and why we sort of allowed this use case in Federation of just, or that's why we don't like warn at least today about the intersection case there.
Yeah. It's also from an implementation perspective, it also makes more sense than intersection. Because it's an output type. We merge all of the output types, so it kind of makes sense to keep it that way. It's just some observation that we had on our side is like if you expose them as a lookup, and depending on which path you go, it could actually be that, or the data contract, the implicit data contract from the semantic means that it actually can only ever be a movie. That's
and you basically, like, let's say on both schemas A and B, you have the same lookup to get object by ID here, and then you have on schema B only the possibility for podcast, and on schema A only the possibility for TV show. Like you have a data inconsistency that you have that. As I said, it's an edge case, but it's detectable at composition time.
It's highly complicated though.
So,
Derek?
I think this is actually falls into similar edge case scenario as well, kind of similar with inaccessible types that are part of the union. So actually that one would be a runtime error because technically you could return like if let's say
Yeah.
a podcast is inaccessible, right? And you try to return that one, well, that will be a runtime error. But it's kind of also leads to the situation that yes, that could be somewhat a weird behavior around those things.
And this also, I think, could be a warning if we want to.
Yeah, but it's really complicated to
Machine?
detect it.
To detect it and also to make it actionable for people and understandable for people what's going on.
Yeah.
Yeah, I mean, if it is the case that object does have a lookup in both cases, and you actually could justify the entire path as the same up until that one point, then in that specific case, you could emit a warning. But there's a question of the complexity there, and there's other maybe technical cases too. But
I mean, the only way to find it out is in satisfiability, because there you essentially go through all the paths, and only then you know that there is actually a path which overlaps, which would return different data with this specific lookup. So yeah. Okay. That's one thing. So
I think Steven still has a question.
sorry.
Yeah, go ahead.
Go ahead.
Should regardless of the shareable there, should it be a warning when you have non-matching union definitions? Like, should this be considered as just like a transient state that you're using in order to evolve a union, or is this something that a graph would intentionally long term just have make use of that intersection?
I think there are valid scenarios for that. Like there are valid schema designs for that.
It goes into the same discussion as with the it could even be a combination with the output only enum. Like it's the same argumentation that we have there, right? Is it a transit state that the enum which outputs data is just not complete, or is it a desired state, right?
But just a refresher on the enum, we do intersect there, right?
Exact match.
Exact match. Exact match.
Exact match with inaccessible. That's the
because it's both input and output.
Yeah.
And we said in this
Yeah. I remember now again.
the magic depending on the position. If it's only used in, so what the federation does at the moment is it looks if it's input only,
Yeah, I know.
output only, and mixed. And
Yeah.
But I mean, with warnings, you could at least, it's a warning. Warning feels also as if you do something wrong, like for the user, right? And
but I don't think this would be necessarily be doing something wrong. Like if you have like media, movie, and media podcast in different subgraphs, it really depends on the path you take to get to that object, because they could be like two different subsets of objects. And in one subgraph, their associated media is always a movie, and in the other one, it's always a podcast. It's only when you have a lookup and that things become more complicated.
That's why I said like a warning is always it's already something wrong. You shouldn't do that, right? But what we like, or what I was interested in is like, is this really what you intend to, like a hook for that? But
maybe instead of warning, this would be just like if there are like we have a thing called Graph Doctor that's a linter, and it comments on your pull requests, and it would be like Michael just said, hey, is this what you intended? Just
exactly.
Yeah, just a kind of a one-time thing when you first make the schema.
I think like the complexity of this is very high to get right.
Yeah, Pascal, I know in this specific case, but you could, like Steven said, if it is not exact match, for instance, you could say, is that already what you intend? Because there are cases around this.
Yeah, we have a bit of the same problem as with the enum as well. I mean, Stephen gladly showed us the statistics in Netflix, and it looked like it's like 20% input, 20% output, and whatever. So it didn't end up to 100% exactly, but but yeah, it's all use cases are valid. We can say a third is mixed, a third is output, and a third is input. So we don't know. Yeah, I would say we keep it easy at the moment, and we just say that we use union as union. We use union with union. And then the second thing is just so that we talk about the same thing, because this also has some weird side effects. About the interface, also is always a hot topic that we discuss a lot. How at the moment, how it's described is we use union as well for interfaces. We don't have interface object in V1 of the specification, so that's something that we can exclude. But at the moment for interfaces, we also use union. So that means if you have two interfaces on subgraphs, you would get the combined result. This also makes sense. The question here, though, is, do you at the moment does this always lead to a satisfiability issue? If there is
no, it doesn't need to lead, because these different implementations of.
I mean, if you get there, right? I mean, because it could be that let's say you have an implementation of this here, and this is we have, I don't know, an ID on it, and now you have a lookup for this here and a lookup for this on the other side, and then you essentially end up in the case that the only way how to get this data could be, it would resolve in a satisfiability issue, because maybe you cannot get the data together just only because of the interface.
Why only because of the interface?
Because you maybe have a path where you have to go through the interface, but when you go through there, like a field that returns the interface, and you don't have the keys in view to transition to the other subgraph.
Yeah.
Yeah, it's actually in 99% of the cases, we don't care about interfaces anyway in satisfiability. It's based on objects anyway. So
that's right. Today we allow this through and essentially leave it up to satisfiability to figure out whether you actually can or cannot reach a field.
Right.
Federation. So.
Okay, good. Then for interfaces, just to fix this, I know we have talked about it before. We also use union, and just for the record, for enums we use strict match. Okay, that's good. That's all I need. Then we can clarify this in the spec text. At the moment, it is, I believe, specified like this. So that's good. Cool. That's it. Let's talk about the hot topic.
Okay, let's go here. I summed up a bit the discussion points from last time, and what the pros and cons of each of the approaches are, just so that we can do a good decision on that. So the discussion points that we had last time was like, is key at all needed in the schema, or like technically needed, or could we just go without it? Like this was one of the proposals. I also posted it in the Slack channel, and I summed a bit up the pros and cons. The main issue that we have here is that loss of explicitness that you have there, and like the semantics getting lost of the schema. We also discussed a second approach to this, where we in general basically say you should use key everywhere where you have a lookup for. You can use key always alone. You can just say, okay, this is an entity has a key, but it's not resolvable through a lookup. It's technically what Apollo has with the not resolvable keys, right? But in general, we recommend that you always have for each lookup a key. Like basically, this is our recommendation, that you have on both subgraphs, even if you have here not for the SKU a lookup on this subgraph, you still should have the key on both if you have a lookup here. Is that correct?
Yep.
Still, it's possible. Like we have the Go ahead, Martin.
Oh no, I just agreed with what you were saying.
Okay. Okay, so and this is also like it has a warning if you don't follow this for any of the following reasons, like this orientate again. So like if you designed a lookup without a key, this is a warning which could be upgraded to an error. And also if you use shareable instead of a key, then this is also
I think there is an
warning.
additional consideration there, but that has more to do with like the lookup semantics, like whether we always want the fields that you map to exist in the subgraph itself. Either that could be as external, but I think that's one of the restrictions we discussed earlier. So you could in that case you couldn't have a find by skew without the skew field at least being defined in that subgraph as external.
Yes, I think I have that in here. If that is the case, the skew, I think that's what I tried to show here. The skew technically didn't have to be here because the wouldn't be needed, but we would still write a warning for that because like it would be like the schema would be semantically more correct if you had the key here. So in both of these cases, you would
I think that's probably something we need to discuss in the context of lookup, whether that's like how strong that requirement counts. Like would we think this is valid, or would we always want there to be a skew field defined, which could be external?
Yeah, I think it would give you flexibility in the like it would make the schema less complex in certain cases. It's again on the edge case field. So I think either decision we make will not change the overall functionality.
No.
Also,
it
wouldn't mean that as it is a warning, it's definitely not recommended to do. But if the need for it arises because for whatever reason you don't have the SKU there, you could still do it. So that's a bit the thing, right?
Sachin?
Yeah, just double check I understand. So we definitely do want to allow, I think, the case where we don't have skew, we don't have the lookup fields available, whether that means marking them about external or not. What I'm a little confused about is if someone didn't have any fields for a key and they were a key in some other subgraph, would they have to add those fields as external in their subgraph and mark it as that key? Because presumably that's a little onerous if you have like, okay.
No, we would allow this. We would allow this, but we would throw a warning.
But only when there's that lookup.
In the current proposal. If we think it should not be a warning, and we are also okay with this, if we have the key on the other side, also fine by me. This is the details we can.
Yeah, so I like the key semantics around that they actually imply an entity. So if we allow the entities without the keys actually be there and without the keys, that's fine. It can be allowable, but as long as it emits a warning that there should be something. So like if that key is not truly there, I think what Martin said with the explicit external field there, that makes it explicit. Because otherwise, I think we're kind of having like a kind of very muddy area saying, hey, you need to do those here, but actually we don't need it over there. I think it gets very confusing enough.
I think one of the reasons for wanting a key for in the lookup case, like the product by skew, one of the reasons for wanting the skew field to be defined on product in this subgraph is because you want the lookup to be validatable just based on that subgraph. Like you don't want, so you want to be able to validate in this case that skew is a valid field on product. Or if you have a mapping that becomes more complicated, you have to validate the is mapping. So if you allow this, then there's no way to know whether product by SKU is a valid lookup without looking at the entire supergraph.
Yeah, I agree, but the composition, like to validate a you need, for many rules, you need to have the context of the whole of all the source schemas anyway. Like, for example, all the inaccessibility rules, all of the default value rules, all of the require rules. It's all, you always have to have the context of everything, right?
Well, no. For require, I think we also
For require, you need it because you
we-
cannot require from your own subgraph. That's
no, but don't we require an external definition in that case, or is that just for
No.
provides? I forget.
That's
No,
we don't need for the
we
require,
don't.
no, but you can, but you don't have to.
Okay.
I think for
Yeah.
requires we do mandate that you have the fields listed in the requires as external.
Yeah,
not
that's
with
what I
the
thought.
That's
That was at least that was the
federation.
original.
That's federation.
Yeah.
Yeah,
that's
yeah.
federation, but in composite schema, so what we could do is just say there's a foo here, and then say require foo.
So there's one thing that we really have to think about when external has,
And this is especially important. Like, think about also the case where you want to integrate or upgrade a graph just with annotations. This is at the moment possible, even with this proposal too. It would, in this case, maybe throw a warning, but you could say, I'm okay with this in this place, or I'm okay with this in general. Is your choice how I deal with that? Like,
Well,
we have this.
what I'm saying is we're letting go of a design principle from Apollo Federation, which might be fine. I just want to make it explicit that we're letting go of this principle because we've always wanted subgraphs to be sort of independently validatable. So we want like require, or in our case, requires and provides and key. We want that to be. We want to be able to validate the string language that's in there, independent from the context of the entire supergraph. And that's why we ask for fields to be defined as external if you require them. It's to validate that there's actually a valid mapping there, and in our case, also to validate the typing.
But think about that, Martin. It's like, first off, in the case of require here, like in Apollo, you have to have it. Otherwise, you don't have the type information. But we have the type information. We know what this thing is, because this has to match, right? This has to be of the type that you require here. Second thing is, you also don't have that the moment we start here with context requirements, right? It's always the contract. This is my input requirement. And this we can validate very quickly also in the moment we merge that, right? We can require, okay, if this field is not of this type, then explode.
Yeah, no. If you have the whole like merged schema available, you can definitely validate it. I just want to call out that like by removing this requirement, we're removing the ability to validate these things within a single subgraph in isolation.
Yeah.
Yes, but my point is that, and I'm sorry, that like this is not there's no real validation benefit here, right? You're just repeating what you have here.
So,
but sorry, Pascal is the next in line.
So two points here. With the specific require use case here with the annotation, I support Michael's point here that you actually don't know, because even if you could define with the external, you can define a field which doesn't exist, and then you run into the same composition error. Like the information that you get is the same thing. Like foo doesn't exist. It doesn't matter
Or
if
foo has a collision.
Foo has a collision, but additionally, on top, I want to make a point about external itself. For me, provides at the moment we only use external together with provides in the composition in the composite schema spec. And for me, my thing about provides and external is that, in my opinion, the current implementation of it with external is just a solution that works, but might not be the ideal solution for the problem at hand. Because external means that you actually put a real field in your schema, which is only resolvable in certain cases. And that's a bit of an issue because this field can be non-nullable, and then it would lead to runtime issues. So in case of provides and external, so from this path you get the field, from this path you do not get the field. It's the only way that we figured out how to do it. But I would really strongly recommend to rethink about any other external use case. Because external essentially means that you have a graphical schema which seem valid, but it's not, because you can only get this field through certain paths. And if you don't get the field, you have to throw an error. And that's a runtime issue, which isn't nice. Do you know where I'm coming from?
Well, for the provides case, definitely, yeah.
Yeah,
it's specifically for like the code first solutions, right?
Yeah.
Where you're actually writing that code. It's actually very easy to hit those cases. I hit those specifically saying, okay, this field doesn't exist, but I need to specify that it's non-nullable, and I cannot have a null there. That's Java. Kotlin doesn't let me do that. I have to have a workaround to make sure that this is not null. And so yes, it is somewhat problematic, but
Exactly.
Sachin?
Yeah, no, for the provide is definitely problematic. I guess we get around that by just saying we never query the field foo in cases where it shouldn't be queried, and that's kind of how we avoid the sort of non-nullable case there, where of error propagation upward if the field is not nullable. At least that's the idea. Behind external itself, I think it was mainly around the idea if a field is defined as external, basically someone somewhere else has to sort of define it, right? Because even in the provides case, you're only partially defining it, right? That's kind of why we reused external for those things. You still have to define the field foo external if it's marked external elsewhere, or even if you have a provides for it in some subgraph. And that's I think was the rationale behind why we did that, but we can always change that if needed. Regarding requires an external, I think a lot of it's mainly for clarity's sake when I see it. I think that, for example, there's a case here where you have a weight and you have this field weight, but it goes off a separate field, maybe like bar, that also takes in foo but has a different type, right? And so in that case, you have a type conflict between foo, and then you have to do this extra work to sort of infer the type in order to be able to check that at subgraph time, rather than as a post-merge validation, if that makes sense. Like,
How do you mean? I don't
Yeah,
know when I have
sort
here,
of
for instance, shipping.
yeah. So suppose on product, right? Suppose you have another field, let's say size, right? And it's of a similar nature where you have a argument foo, let's say, and foo is I don't know, boolean, right? Let's say, and then I also have at require field foo, right? In that case, this is also wrong. You technically take the time to infer what the type of foo is if they're incompatible. But it's easier to notice this if you actually define foo as external, and you know it's exactly one of the X things.
Yeah.
Like it brings more mental complexity to sort of have to infer what the value of this is in that case.
Yeah,
if that makes
it
sense.
also makes writing the validation rules easier because you basically have two
Yeah.
stages. Like the first stage is something you can do at the subgraph level, so that's parsing like the field expression in require, and mapping it to a field that needs to exist, that's marked external. And then the second stage is for each external, there needs to be like a corresponding and compatible field defined in the merged graph.
Yeah,
So you
Yeah, I see.
break it
I
up into
see.
two separate stages.
I see what you mean, but like when you look from especially from implementation first standpoint, code first, then you always are in the code context, and you would require this to be a string. Then to have an additional thing here.
Well,
But
that does nothing.
Why would
It's
that need to
always
be a
invalid
string?
code.
Like how do you
What?
well why does foo need to be a string? Like why can't it be a boolean? How do you detect that? And at
It
what
can-
stage do you do that?
Yes, but it's the same contract that you have anyway. Like if I did this wrong, and I could do this wrong, right? Then I also just find out when I merge that with the second product on the
Right.
other subgraph that
Can-
actually is a string.
Can you undo quickly and have the example with the two fields with the different types? Because there's a third case here, right? Exactly this. Keep it like this. Now change foo to int. Like even
This
if
one?
yeah. No, the one the value of foo of the field. Yeah, it's fine. We have 3 different types now. So even if the field is declared as external, you can still mess up.
Well, you can mess up, but you now have a source of truth. So you know that foo string, the external one, is what you.
Is it?
That's the dependency that you declare, and that has to be compatible with the requires in your subgraph.
Right.
And
For subgraph
that's what I doubt. Because why is this a requirement?
So
Actually, this is my requirement. This
Right,
is
right.
just another field definition. It could be the same thing. It could be also wrong in the end on the other side.
But the reason we also named this external is it's sort of similar to like in a C-like language, right? You in order to use an externally defined variable, you define sort of a dependency. Like the extern is just a dependency. It's just saying I expect there to be, for instance, a global variable with this type. And in this
So-
case, it's a field. So what I think this reduces complexity because you can parse and validate the requires at the subgraph level with just one dependency, one explicit dependency, which is saying my subgraph expects the type foo of product to be string, and that's
So
But
when are we talking about the subgraph
Actually,
validation? Are we talking about the libraries to do that? Because I thought one of the goals was actually to avoid custom libraries that would allow you to do that at build time, right?
that's also where I'm coming from.
If it's part of a
but
composition, we also have a step that validates those, but like there are, that's I think it's nice in a way to have these external fields, but there are some areas that are probably not ideal.
Because one thing we could also, like, this is validatable on a subgraph level. The moment you have 2 different requirements of the same field, it's a subgraph level error.
Sure, but the way you would like define and implement these validation rules is a lot more complicated because you now have you have this weird intermediate state that's saying you're basically calculating the expectation that the foo field of product is of a certain type on the fly.
Yeah, the first instance you find, you say, okay, if there's anything other than Boolean, then accept.
I mean,
this basically means that in order to write a validation rule for require, you need to look at all requires in your subgraph.
well, we don't.
No, all requires on this type.
This
or on this type in the subgraph. Yeah,
this would only be necessary if you have this use case. Like in the composition, we don't need to validate, as we have the post-merge validation rules, right? We don't need to have this validation. It's not required to do this validation on subgraph level. From a spec perspective, it's much simpler to just let it merge and then validate it afterwards, because then you can validate 2 things at once. You can validate that the type is correct, and you can validate that the requirement is correct. So that's the reason why we do it currently as a post-merge validation rule. And this would actually cover both. You can infer it as a source schema validation, but it's much more complicated to describe it this way. I'm with you there. It's more complicated to describe it rather than just merging it and then validating it, because then it's very easy, right? You just check if the field matches the spec.
Sachin?
Yeah, I think the other reason we have external to some extent is it declares it clarifies the mental model for subgraph authors. It's a simpler subgraph authoring experience in some sense. Or that was what was intended, at least, I think, to some extent. In the sense that you have subgraph authors declaring, I want this field foo, and I expect it to be of this type, and then I can use it as I please in other places and requires or whatnot. and in this sense, it's sort of now hidden, and that sort of expectation is hidden. And it's less explicit on the dependency, but yeah, in this case, I guess technically you can infer as a post merge validation. It's just maybe less explicit in this case. So,
but I also think that the problem is if you what you do with the externals is really a lot of complexity on implementation first approaches, right, from GraphQL, because like the SDL in this case is just an artifact of the code that you write, and you have to write invalid code. It's the same thing we do in the C# implementation for proliferation. It makes all the authoring like a lot more painful because you have these invalid states.
do you mean in the sense that there are extra fields that actually can never be returned and they don't really exist? On
Yes,
the
or they actually are not nullable. You have this guarantee there, but they accept in 90% of the cases.
What?
And like there's also a thing like the composite schema subgraph should be just a valid schema of its own, even if it's built for building a composite schema that is made up of many subgraphs. It should also be like a valid GraphQL schema on its own. And by having external for these cases where it's not necessary from the GraphQL semantics, we are just building an invalid GraphQL server.
Could you elaborate a little on the invalid GraphQL case of a
because like if I define, for instance, that foo here is non-nullable, then this is never be nullable, right? And I expect also that I can just query it in all the cases. Like this is just a field. There should be no execution error that I expect, like just a random execution error, because there are no arguments into this field. This is basically an atom, a leaf field that should just be there. So I expect here no special treatment just because it's annotated with external.
Query it in isolation.
Yeah.
No,
You
you can never. So that's the difference with this specific thing for require. This you can never query. This field, you can never query this field in no way, never. With provides and external, it's different because you can query it in some cases, and with the key is also you could query it when you come through the lookup maybe. But in the case of require, you never query the field because you just do not expose it, right?
And in that case, it wouldn't even need to be in the GraphQL schema. It can just be in the SDL.
So that's
but then
the weird thing there is that we need it for provides, so you still
but the code first ones don't have that.
Yes,
so that's
because you
thing,
have
like...
to push it then in there. You cannot just have it there. Otherwise, you will suddenly have to write two definitions. The implementation first definition plus a little bit SDL extensions. And that would be a horrible DevX.
So
with this you have a very, very good user experience because like you're defining functions, and in this function you define your requirements, what you have. You have the type here declared, and you could even have this SDL compile on its own. You just have to have one validation rule here which collects in one type all the requirements and makes sure that they match up to the same type. And then in the full merge, you can even validate it against the larger whole.
I think the point here being that we can. It doesn't matter if we add dependencies or not, but to the fact that external would be definitely the wrong tool for this. Like we would need something which gives you less guarantee and which is not in the schema for both cases. Like the only way how you could define this dependency would be to introduce something completely new, because external would be, and it's a hill. I've discussed this so long with Michael when he showed me the provides external use case. It's so weird to have a field which you cannot query in your schema. So external would definitely be, in my opinion, the wrong thing to use for declaring a dependency like this. Like if we need, like if it's a requirement for us when we agree on that we need to require dependencies, then we need a new tool. That's just, we just make it more complicated then, because then we have a whole chain of things that we have to think about.
I think what's confusing here is that there are really two different use cases for external, at least the way we originally thought about it. And I think at least I at that time wasn't really thinking about the code first approach. So I was thinking about this purely from an SDL perspective. And I think the original use case for external was exactly that sort of dependency and something that wouldn't need to be in the GraphQL schema itself. It's just to declare a dependency. But then we reuse that for provides. And provides is a very different use case. It's basically saying this is sort of a path-dependent field. So, I mean, I don't know if we want to introduce even more complexity here, but if I were to think about this again, maybe external in the provides case is not the right term. Maybe you would want something like partial or something, something that signals that this can only be queried when you go through a specific path. And then the external case is just about declaring that dependency. And if you can't rely on things being an SDL and not in the GraphQL schema as in the code first approach, maybe that does mean you need another mechanism for that.
Sachin?
Yeah, big plus one to maybe renaming how we indicate for provides fields that they're sort of partially provided. And also another plus one to the notion maybe I think there are other tools we could potentially do other for the code first approach, at least to help those folks to get their fields to be indicated as such. Like you could potentially have directives on the type, although it's a little bit cumbersome, but yeah. I'm not for another optional thing we could potentially do there, but that doesn't necessarily have to be mandated or in the spec, not even.
Yeah. And in the spec, the simplest approach might be to just say we expect there to be always the full context of the merge schema to validate these things again.
It's also important that the SDL as a thing, like Facebook only thought of this is just to print out what the implementation first approach they built GraphQL with could just be represented. That's also what Lee said on several times in the core working group, like that he never intended for something like schema first, right? Just saying, it's to just build this around schema first, we get into not nice experience for a lot of implementations.
Yeah, you actually opened another can of worms, Martin. I need to think about this, but partial would be far better name for external in the provides use case.
Yeah.
But anyway,
I agree.
But provides it's a separate case, and there.
And I'm just to make one thing clear here. I think that this probably in the specification this has to suffice, because the only thing which I now think about is if you have a requirement which requires a subfield from a different subgraph from a data field, then you run into the collisions that you now have to define somehow a real field, but also the external part of, it goes, as soon as we have dependencies on the type, we run into all the restrictions that we already have, right? Like, for example, the issue that we had with lookup, that you actually have a field in the graph in your SDL that has a name, and this name is, there can only be one field with this name. So when we start introducing dependencies and whatever on different subgraphs and so on as fields in types, then you also have collisions between these things. Like if you want to require something nested, like that dimension dot width or dimension dot height, maybe you expose dimension. Maybe you also have a property for dimension, like dimension dot whatever. size, which is a calculated property on your subgraph. And then you run into all kinds of issue with how would you define this dependency correctly, and yeah, it's complicated. Really complicated.
Yep. But good discussion.
Yeah.
So we kind of got derailed, I think, from the
I don't
topic
think
of
so.
having the lookup and the keys. It's
No,
all
yeah,
great conversation, but like the original question was about the lookup and the keys. But yeah, that's we probably should spend some time talking about the external fields and all that stuff. But yeah,
But it's because it's related, right?
Yeah.
Like in principle, the lookups have here also requirements, which we express with is, but it's kind of the same mechanism in the end.
Yeah,
That's why
that was why this that triggered this discussion, and I think I think it's clearer even in the lookup case, because it really feels like you're missing something here, like especially maybe for the implicit case here. But so if you have to infer here that product has a skew field, and that it has a certain type.
Yeah,
And that's another like dependency.
The thing is, I don't want to like the place I don't want to be in is that you have to design it this way, like that you can just do it like this. But if you want to, I don't want to forbid this, right?
Well, now
If this is
we're talking about two different things. We're talking about the lookup
Okay.
stuff again, right?
I'm sorry?
We were talking
with
about
the skew here,
yeah,
Yeah,
exactly.
but it's the same idea. Yeah.
it's the same.
So there's one case here that we just if we always need to re-expose the things if there's no way around this, like we can say this is best practice and this is how you should do it. But if there's no way around this specific behavior, even though it's technically possible, then there will be a use case where this will be used and it will become a problem. For example, you have a REST API where you can get something by SKU, but in the REST response, there is no SKU. So now you have to actually start fixing this somewhere into it that it actually re-exposes an SKU, right?
I actually think this is not a use case for external, but for partial, if you want to go down that route.
No, I mean, it's just like if you can just say that you can look this up by SKU, because in my domain, I know SKU is a key. And then I have a service which does a REST call, but the response from the REST call doesn't contain the SKU. Now I have to add more stuff to it. I either need to make it external, and then it's kind of weird because it's not queryable. But yeah,
It's not queryable in all cases, you mean?
yeah. I mean, it's never queryable in this case as well. Like,
Yeah.
You don't know if the external field is actually a field that you can query for or not. Like you don't.
In this case, like we have two tables. They have two keys, could even be designed like this. And depending which field you come through, you have one of the keys, but not both.
Yeah, but that's even the implicit provides thing. I mean, there's another use case with the API.
But this is without provides, right?
Yeah, but it's an implicit kind of thing, right? The other thing is when you actually when you just want to integrate an API and this API doesn't return the field, then you have to do the same stretching exercises, right? Like you don't know if this external field is queryable or not. There's no way to know.
I think that's a slightly different case though, but because in the mapping to a REST API, you can actually describe the fact that like the skew always has the same value as the input skew, for instance. I mean that's a property of the mapping in that case. That's how we do it, for instance.
So, but let's circle back on because I want to also try to make some progress on this. Are we in general okay with this, with the second, which is like the in between. Like we recommend people into writing it a certain way and do it with warnings. But you can, in essence, opt out. And you can also have these cases where you don't return it. You don't have an external, but you can have an external. Because that would be the most compatible, but in general, also very strict.
So to clarify, if you had a lookup that didn't actually serve the fields, means they weren't on the type, in that case, would you omit a warning then there's no key? Or would you say that you would there be a warning or no warning in that
So
case?
let's quickly do the. So this is the ideal case, right? We have it on both sides, and that is actually what we want. This is green. If we have now this guy here, let me just quickly copy that over. And second, this guy here, this also would not warn because you have a key. This is declared here, you own it here, but you didn't re-expose it here because like it's you don't want to have it as external. It would also be green.
Okay.
Yeah. But I think the question here is what if on subgraph B you do expose skew on type product? So on line 22, let's say.
Let me introduce here the A and B so we navigate correctly. So on line 22.
Yeah, or 21. Yeah. So if you define skew here, just as a string, as you would normally do, I think one of the questions is this valid? And I think
this would be an error.
It would be an error because it needs to be shareable.
Yes.
But do we want to say something
this
even
would be a
stronger?
warning.
But do we want to say something even stronger here, which is skew is not just a shareable field, it's a key field. It's been defined as a key field in subgraph A, so it should also be a key field in subgraph B, because a key field is stronger than it just being shareable.
The main rationale here to allow this is for schema evolvability, A, and B also because that is an Apollo legacy.
Yeah, but I mean as a warning.
We could say that the moment you make it on one subgraph a key, it has to be everywhere a key. But is that what we want to do?
I think that is the ideal case. That is sort of the semantics we want to go for. If you define skew on a subgraph and it's a key on another subgraph, you should also mark it a key, I think.
But this could cause a lot of schema evolution headache if we don't make it a warning. Like with a warning, you can always say, I want it be an error.
I mean, I'm talking about making it a warning, not making it a...
Yes. Yeah. Yes, this is a warning. Like in proposal 2, this is a warning. It says, in both cases, the composition will issue a warning if lookup uses fields of an entity that basically this case.
Okay. Yeah.
And one question here to Stephen. If you now think about your graph and you have take the entity which has the most usage across all the subgraphs, how much of a headache would it be if some subgraph now says that it needs a new key, like a composite key between, I don't know, SKU and product name or something like this? Like, what would that mean if then it's like we want to have no warnings in the compositions, we want to follow this pattern, and then we just have one key that we have to pull through different teams so that we don't have the warning?
So in this case, in order to not have the warning, well, there wouldn't be any way to do it without a warning unless you make all the changes atomically. Is that right?
Yeah. The good thing about warnings is that you can say you want to ignore the warning. That's the reason why a warning problem fits. But I'm just wondering the impact if you actually. It's more about. I think we agree that the key should be best practice on the field that actually defines the lookup on the subgraph that defines the lookup. I think that we are all in agreement there. But should a key, is the desired state of a key to be spread across the whole domain is the other question, right? Should it be, even if I don't have a lookup, should I still be the ideal case that I define this as a key as well on the other subgraph? That's a bit the question here.
Yeah,
Because-
but
Yeah.
in this
so,
case,
so
yes.
if you don't have a lookup, like for a subgraph that doesn't have a lookup for an entity, what does the key necessarily like mean to, in their subgraph?
So
I mean,
so the idea
at a minimum, it marks all the key fields as shareable. But I think the argument
Okay.
here would be that it's actually saying something stronger that doesn't have any
Yeah.
practical consequences right now. But like a shareable field might still like change at any time, and a key field is meant as sort of a stable identity.
yeah, because this would
which also means
also
that you can use it as a cache key, for instance.
yeah, this would also be a warning, right? In this in proposal 2, but even if C doesn't have a lookup for SKU, because like there's the shareable semantics that we have here now is not just that this is the same, but that this also is stable. Like because I'm saying here this is a key. And we have here lookup for it. Actually, let's clean it a bit up, because like we would still have a warning now. No, so we would still have a warning because this subgraph that might not even have an SKU lookup has this as shareable, and like what was the not agreement, but the consensus last time was that the moment we make SKU a key somewhere, then the shareable contract should be this is a key, this is stable, and the teams should communicate on this.
Yeah, it's important to know if you define a SKU field in subgraph C, it's important to know that other subgraphs consider that field a key. That was the idea.
Yeah, and I guess in Federation today, it's a bit ambiguous because every subgraph that has an entity is kind of assumed to have a lookup, I guess.
Yeah.
Even if they don't actually have an entity resolver in the graph, you can't know that.
Yeah, I mean, we have the resolvable false argument that you can use in that case, but
Yeah.
But I don't actually know how widespread that use is.
Right. Yeah, it's not enforced.
No.
Yeah,
Yeah,
but
again,
in that
with the
case, it's
entities
now
also-
very this is now very clear, right? This is
Yeah.
a resolvable false key, a key, just a key, and as soon as you put a lookup for that somewhere, it's resolvable.
Okay.
So I take that we are generally okay. I mean, I write it up as spec text. I also will introduce another chapter just for a bit more abstract on entities and keys that I put in front of the chapter that we have on the directives, just to get more semantics about what we mean around entities and stuff. And then I will update the directive description with this semantics that we discussed. And then we can reread the spec text.
Yeah, sounds good. And we can always like refine option 2 further, like as we go through different scenarios and sort of define what the warning should be. We might encounter other situations.
Also,
yeah.
I
mean, it's the same way we reopened lookup in general.
Yeah.
Because we thought it was not clear enough. When we at some point find anything, we just reopen it. There is at this stage, in the proposed stage, we can just rip it apart whenever we find it doesn't work out.
What I really like about proposal 2 is that it kind of allows you to do both things in a good way. Like even the very strict one that you said, Martin, with entry and exit, that you actually want to would specify the exit key so that you exactly know the routing and everything. you can do this with this approach. You just have to propagate the warning to an error. And then you actually can do this. You can specify exactly this behavior as well.
Yeah, I think the difference is, but like we don't do that with Federation today either. But potentially, like if you define explicit exit points, you could use that to maybe simplify query planning. But that's definitely not something we're doing or even planning on doing. It was just it was more of a thought exercise.
Yeah. Yeah. I think it's really flexible.
It would be nice, but at the same time that would break the evolutions, right? So if you have a field and someone adds it in, well, fails the composition, but it means I have to now talk to the other team that I never talked to fix their graph, right? Which is people problem, I guess, but it is.
Yeah, you don't
Yeah,
want to
but in
talk.
this case, you can also say, I don't care about this warning, right? And we just play as we did before.
Yeah, but I think like when you have those, it's you would configure it, it's either a warning or an error, right? So you cannot have, on those cases, I would have it as a warning. In other cases, that's an error, right? So
I mean, this is like, to be honest, this is like we define what a warning is, and you can upgrade the warning to an error or ignore it. And there might be solutions where you even ignore. This depends on, maybe Apollo Solution Studio has the ability to ignore in locations. Could also be like there's the implementer fantasy that can go wild.
Yeah. We promote warnings to errors, but just on weekdays.
Yes.
Something like that.
Yeah, but this gives you the flexibility to build whatever around you want. Like you could have a location which defines a subgraph plus a schema coordinate, and then you ignore it on this or whatever.
Yeah.
Okay, that's good. I write that up, and then we can move on next time.
Yeah, I think we
More
have
in
a public one, like the main
public holiday.
No, a main meeting
A
next
public,
week.
yeah.
Yeah.
Yes.
Primary,
Yes,
that's the
then
word I
we
was looking
can.
for.
Yeah,
It also
yeah,
starts with P, but has a very different meaning.
yeah. I was thinking public holiday. I know. Okay. Yeah, I read that up, and then we can also share it if someone else is there. Like if I don't know, people are there that are not in our typical round. Otherwise, we can continue on validation.
Yeah.
Because there is a lot around satisfiability. Awesome. Then see you next week.
Yeah. Thank you so much.
Thanks, everyone.